Bienvenidos, Ushamdi, and welcome to this Cisco Networking Academy Emerging Technologies Workshop tutorial on how Python lists are implemented using CPython, and we're going to be discussing communities of practice and the important role that communities of practice can play in learning the Python programming language. This is a supplemental tutorial that is addressing one of the questions that was asked toward the end of my Python presentation on Thursday afternoon regarding lists, and specifically how many elements could you put into a list, and then how are those elements being referenced, and what happens if that list needs to grow. And this is where the communities of practice can really help us out. So let's go ahead and take a look here at first the Python documentation. Now, if you were to Google how lists are implemented in CPython, chances are it would bring you to one of the links at python.org. Now, this is for 3.7.1, which is the latest and greatest release of Python or CPython. And as you can see here, CPython's lists are really variable length arrays. There was some discussion among the viewers that it might be some sort of a linked list implementation. However, it's not. It's simply a variable length array. And I had used the word chunking when the array needed to grow. And in fact, that's kind of what's happening. That might have not been the best word to use. However, when the list begins to fill, it will then go ahead at the point that it needs to expand its size to accommodate the number of elements in the list, and it will automatically grow the list by some variable amount. And we're going to be taking a look at the exact code that makes that happen. So a list is a variable length array, and if you think about it, this makes a lot of sense. We wouldn't use a normal C array because C arrays that are not variable length are then fixed length. In other words, we would have to declare at the very beginning what the size of that array would need to be. So let's go ahead and take a second here and let's take a look at the C programming language and let's see what a regular vanilla array implementation would look like. So I've actually already created the code, that way we don't have to sit and type a whole bunch of things out. So if I was to say vi array1.c, you can see here that this is C code, clearly not Python code. So we've got our include for the standard input-output headers. We've got our main declaration. And you can see that the array, my array, is going to consist of 5 integers. With an array in both C and Python, all members must be the same data type. Now, pay special attention to what I just said there. In both C and Python. So you may be scratching your head wondering, well, wait a second. We're talking about lists. Are there actually arrays in Python? And the answer is yes, there are. And we're going to take a look at those as well. And then we're really going to see the flexibility and the power of the Python list. But again, let's digress for a second here and take a look at how an array, a regular non-variable length array, is going to function with C code. And so you can see I have to clearly define the number of elements that will be in my array. And more importantly, I have to define the data type that those elements in the array are going to be. So here I have to say that they're all going to be integers. In fact, if they're not all integers, we're going to get an error. And I will force that error to happen here in a second. And so this is one of the significant limitations of a regular array, is that you must declare the number of elements in the array from the start. It's not expandable. I would have to come into the source code and then change it in order to accommodate additional elements. And more importantly, everything needs to be the same data type. So if you're thinking about the Python list, that's a huge advantage. Is that, remember, with the Python list, I can put in any other data type I want. Remember, it's like that shopping cart when I'm going through the grocery store and I'm grabbing items from the different food groups. All of those items from the different food groups, dairy or meat and fish or grain, those will all fit into my Python list shopping cart. In a regular vanilla array, in both Python and C, that's not the case. You can't do that. And so that's a significant advantage that a list has over an array. And so if I was to save this file, and then if I was to compile this file, and again, this is one of those things when we talked about the difference between interpretation and compilation, the takeaway here is that take a look at what I have to go through every time I want to update this C source code file. And I'll just call this array.1. And so all this command is doing is it's using the GCC compiler, which is a C compiler from GNU. And that's my source code file. And the -O simply represents the name of the output file I would like to use. And so my program is going to be called just simply array. I hit enter. We don't have any errors. So if I say /array, the program is going to run and it's going to simply print out exactly what I told it to print out. So now let's go ahead and break this. Let's prove that we can't have different data types in the array. So if I was to vi array1.c, and now I'm going to have to come in here, I'm going to add a 6th element to the array. Right? So in my declaration statement, and again, remember, when we say in Python from the interactive interpreter, when I say, and let me demonstrate this, let's type in Python 3 and fire up Python 3.7. When I say my list, and then I simply put the elements of the list in here, we'll put a string, I'll just simply say my string, and we'll leave it at that. The takeaway here is you don't see me having to say my list is going to contain this many elements, right? And they're all going to be of this type, or here are the types that will be in my list. I don't do any of that. I simply type in my list and I put my elements in there, and that's it. Now, contrast that and compare that to what we're having to do here. I have to come into this array, and again, this is the C programming language here, and now I'm going to add a 6th element here at the end. And we're going to make it a float. So I'm going to say it's 39 or actually, let's just do this. We'll put in 3.141519. I think that's something close to what pi is there after the decimal place. Now, in the C programming language, what is that? And it's the same thing in the Python programming language. That's considered a float. So now I have an array with 5 integers and a float. But is that going to work? In fact, I'll even come down here and go so far as to put in a print statement, and we'll change this to the 6th element of the array is, and let me change the definition here to a float, and my array at index 5. So let's save this off, and now let's compile it, and what we should receive is an error from the C compiler telling me, hey, you cannot put different data types in the same array. And take a look at what we get here. Implicit conversion from double to int, change value to 3, my array, and the format is, the format specifies double, but the argument has type int, right? So again, my declaration says that everything in the array needs to be an integer, and here I've dropped in this float with a decimal point in there. So we've got a problem. This is not going to work. Now, again, remember, I'm saying that Python also has arrays, and we will get to that. So let's go ahead and take a step back here and go back to the Python documentation. So it's a variable length array. But you now may be asking yourself, well, wait a second. You just showed me that in an array, all of the data types that that array contains need to be the same. And this is true, and we're going to get to the reason as to how Python gets around that and what the structure is that addresses that shortcoming of an array. So again, it's a contiguous array of references to other objects. It keeps a pointer to the array and the array's length in a list head structure. So again, when we index into the array in Python to get the elements out of the list, we simply type in the name of the list, the open bracket, and then the integer or the index location. And remember, it's a zero-based counting language. So if I were to pull up the list that we're working with here, when I say my list 0, that's going to give me the first element, or 3. If I say my list -1, do you remember what that does? Yes, that's going to give me the string at the end of my list. It's going to give me the last element of the list, irrespective of the number of elements in the list. So my list -1 ensures that I always get whatever the last element is. In fact, let's grow this list out. If I was to say my list dot, and actually if I hit tab twice, you can see it's going to give me a list of the methods. Remember that methods are different than functions in the sense that the method is a function, but it's inextricably linked to the data type that we're working with, right? So in other words, my list dot append, this is inextricably linked to the list data type. And so we call this a method because it works, but it works only with this data type, right? The list. So I say my list.append, and then I can go ahead and put in, and let's do a dictionary. So I need a key, we'll say key1, and then we need a value for that key. And I'll just say 8675309, Jenny's phone number. And so there is a new element that we are appending to the end of my list. So now if I was to come back and say my list -1 and index to the -1 location, which is always guaranteed to be the last element of the list, we get the dictionary that we're looking for. All right. So again, as I'm adding things to the list, right, I'm able to do that. Now, when it says it references the list, I use the ID command, and this is what started the conversation around, well, what is the list doing behind, under the covers, behind the curtain? How are these things being handled? So if I was to say ID my list, that number that I get right there, that is the location in memory that references this variable name, or that this variable name my list references. And what that is, that number 43199191112, what that is that is our list name. And then that list name is nothing more, it's a pointer to that list name, it's nothing more than a series of other pointers to the other elements in the list. And how can we see that? Well, let's pull this back up. And what happens when I say ID my list, but then I say I want the memory and location of the specific element out of the list? And you can see it's different. So, and that would be, is that the number 3? The integer 3 in our list. Well, what about -1? Is this going to work? Absolutely. And take a look. All of those numbers or those ID locations in memory, they're all different. And so think of it as sort of like a hierarchy. We have a reference to the list name, and then that list name is a series of pointers to these other data types. But again, you still might be asking yourself the question, well, wait a second, you keep saying it's a dynamic array, but we just talked about arrays, and you said that in an array, everything needs to be the same data type. And that's a true statement. Now, in order to solve that mystery, you can see here when items are appended or inserted, the array of references is resized. Some cleverness is applied to improve performance of appending items repeatedly. And when the array must be grown, so it doesn't actually grow the array by one element. And then if you added it in, if the array was full and you add another element, it doesn't just say, okay, well, I'm going to grow it by one element. What it does is it is clever. It's very Pythonic in the way that it grows the list behind the scenes. And so let me iconify that. And so now I'm going to weave in the conversation of the communities of practice. And one of the communities of practice that we've talked about is the community of practice StackOverflow. Now, in my opinion, StackOverflow is quite possibly one of the richest and most valuable resources for any programmer, and especially Python programmers. It is a community where there are literally tens of thousands of individuals sharing their subject matter expertise. And so what I did was I Googled how are Python lists implemented in StackOverflow. And this is what I came upon. And this is absolutely fantastic from a resource perspective. So remember, we're talking about CPython. And remember I talked about JPython or Jython, and that would be the Java implementation of Python, or it's going to be compiled with the Java compiler. With C, it's being compiled with the C compiler. And that's why I was showing that C code for the array and what we would have to do. So here is the actual C code, and it says it's pretty simple. If you're not familiar with C, I'm going to give a very high-level analogy as to what's going on here to try to make this easy to understand. So here is the structure or the data type definition for the Python list object. So to pull this back to why did I show you the C code for an array, and why did I harp on the fact that when you have an array that's just a vanilla C array, that to make it larger, you would have to go in and change things. And then why did I drive home that point that everything in there needs to be of the same data type? And this is why in the code, in the C code that is Python, in other words, the code that when compiled gives us the CPython executable that we're running when we say Python 3 from the command line. This is how the list is created. So basically, think of this as the C programming language equivalent to creating your own data type. In Python, we might say we'd be creating our own class. And in that class, right, we would define traits or characteristics that that new object would have. And in C, this typedef struct, and this is the type ID. In other words, that is the name of this new data type. And then what you would do is you would instantiate or create new structures of this data type that represent the list. So when we type in my list and then equal and then the elements of the list, we're really creating a Python list object. And so this is why we're doing it in a dynamically expanding array. And this is how it's done. And what's happening here is you can see it's a vector of pointers to the list element. So list 0 is object item 0, and then list 1 would be object underscore item 1. And so it's nothing more than a series of pointers that the lists represent. And those pointers point to the items or the elements in the list. And then take a look down here. It talks about how the resizing of the dynamic array takes place. And again, we don't see this, we see the list. And that's what we're working with in Python. But behind the scenes, this is what's going on, and this is how it happens. And it's definitely not a linked list. It's a dynamic array. And there's a lot of confusion between a list in Python and an array in general, because you say list, but it looks a lot like an array. But it's not using a regular array, right? Behind the scenes, it's a dynamically expanding array. And because we've defined this new data type here, right? This new typedef structure, we're able to then add elements of different types, because all we're really doing is adding a pointer to that new data type that's an element in our array. We're adding a pointer that references the location in memory as to where it resides. So if I come back to the screen here, take a look. So the top level list, or the head of the list, that's the reference to it. The first element, we simply have a pointer to that location in memory. And then we have a pointer to the last element of the list, and that's the location in memory. And so the list, think of it as nothing more than a series of pointers that point to the location of all of these different, or what could be different, data types that make up my list. And this is how I'm able to pull back those items in the list, and this is why we're able to put elements of different data types into a list, and why we can't do it in a regular array. In fact, you'll notice that it's just simply a Python object, and we're creating a pointer to a pointer, right? And that is how we're tracking things. Now, this list object.h, if you click on that, it brings you here, and here's the actual code from where that screenshot was taken, and it gives you much the same information here. And again, you can see that this is all part of this header file, right? And it talks about how it's constructed. Now, again, back to the communities of practice. So I wanted to know, why doesn't Python call it an array? Why does it call it a list? Because a lot of times this will cause some confusion. And so here is a great explanation as to why Python calls it a list. They're named after the list abstract data type, not linked list. And again, the confusion between list and array is just as evident here with the difference between list and linked list. So Python calls it a list, and that may give you the impression that, oh, okay, so it's not actually an array, it's just a linked list. That's how it's functioning behind the scenes, when in fact that's not the case. So it's a dynamic array behind the scenes. It's not a linked list, but it's named after this list abstract data type. So let's click on that link here, and it takes us to Wikipedia. And a list or a sequence, it's an abstract data type that just represents some countable number of ordered values. Now, the same value may occur more than once. That's fine. They don't have to be the same kind. So again, it's sort of this theoretical abstract called a list, which is just like a list of things. And that is exactly why we call a list in Python a list. It is just simply a list of what could be the same or different data types. However, behind the curtains, the way that it's being done is right here. And we also saw on the previous screen what happens when the array fills up and the array size needs to increase, is that it will dynamically increase the size of the array. But again, the array's not holding all the same data. It's just holding pointers to all these different data types. All right. So again, you can create in C sort of your own data type definition. And I wanted to just touch on that briefly. I've got a really short example here of how we could do that. So if I was to say VI, and I think I called it struct1 or struct.c. So here's a structure right here. And again, trying, the code on the Python site in the documentation there is a little more difficult to understand. So let me try to give you a very simple, easy to sort of logically sort out example here. So we've got typedef, and here's the structure, right? So the structure is, here are the traits and characteristics of the, and what's the word I'm looking for? It's not the variable name, but yeah, basically it's when I instantiate the variable name, building 1, building 2, this is the structure that those variables, or those, think of it as an object. Again, I'm analogizing here. Think of it as an object, but in C, they don't call them objects in this context. So again, but we're going to think of it as like an object, and that object has traits and characteristics. And I've just created sort of this new object class, right? This new data type definition. And here's the structure. So every instance of this data type inventory that I instantiate, it's going to have 3 characteristics. It's going to have an integer number of routers, an integer number of switches, and a float as just sort of the daily average of the number of devices. And the reason I put that float in there, and you may be scratching your head saying, daily average, what is that? This is just here to make it a simple example that they don't have to be the same data type, that I can put different data types as my traits and my characteristics of this new data type definition. And so what is the name? Well, the name is inventory. And so I've just created a new data type definition with the structure that you see here, and the name of it is inventory. So if I wanted to instantiate instances of this, right, I would say inventory building 1 and building 2. So now building 1 and building 2 are variable names that now take on the structure of inventory. So building 1 can have, and we'll see right down here, it can have a number of routers, it can have a number of switches, and it can have a daily average. And this is how I can get around having to keep things all the same data type. And then you can see here, building 2, I can have number of routers, number of switches, and daily average. And so then if I had a third building and a fourth building, and you can sort of see the pattern that's developing here. But again, this example is more to kind of just give you an idea as to how that typedef structure could be used, right? And to sort of understand what's in there and how those traits and characteristics that make up this new data type definition and the structure of it, how they can be used. And then you can see down here, I would simply say the total number of routers at building 1 is, and then at the very end, it's building 1 dot num routers. And I'm able to do that. So building 1 is not being declared an integer. It's not being declared a float. And building 2 is not being declared an integer. It's not being declared a float. It's being declared a data type structure of inventory. And this is what makes up the data type structure inventory. Okay? And that is the same sort of approach that's being used with the Python list and circumventing the limitations of an array and the performance drawbacks of a linked list, right? It's much quicker to simply reference a pointer somewhere in an array, right, dynamic or otherwise, than it is to have to work your way down a linked list. So let's save this off and let's run this. And I actually will compile it here real quick, and I'll say struct.c, and my output file, we'll just call it struct. And oops, sorry, I wanted a -o there, my apologies. So there we go, and now I'll say /struct, and there you go. And that's it. And so in C, right, kind of think of it that this is one way to do it. There's many other ways to do this, but this is one way to sort of create your own little special data type, right? That is not an integer, it's not a float, it's not a character, right? And it has different traits and characteristics that you can then tap into and use. And so if we take one last look here, right, we did the exact same thing that you see here in a much simpler and easier to understand format. But again, I'm just instantiating, right? You got this PyList object. Mine were called inventory. And we did much the same thing. And it's just pointers to pointers that go into these dynamically expanding arrays. All right. Again, this is how communities of practice can be extremely, extremely helpful. And I think the last thing I wanted to touch on is I kept saying, well, there's arrays, right? And if I were to roll up here, and remember I said that there's arrays in Python and that a lot of learners will confuse a list with an array. Maybe they've had a C programming course and they've seen reference to something that looks like that, but it's typically called an array, right? In Python, it's a list, but Python also has arrays. And so again, I'm in the documentation for 3.7.1. If you were to simply look up efficient arrays of numeric values, you can see here that we can use integers, and you have to use a type, right? And this is going to be, and the reason this is important is for the reason I explained when we looked at the arrays in C, that C source code file where everything had to be an integer. The same is true in arrays with Python. Whatever data type I declare the array to be holding, that array can only hold that data type. So let's take a look and see what that looks like here. Let's go back to our Python interactive interpreter. I'm going to do a Control L and clear my screen. And let's go ahead and create a list. And I'm simply going to call it my list. And actually, I apologize. We want to create an array. So the first thing we actually need to do, and let me do this. I'm going to say Control D. We're going to go in from scratch. If I say Python 3, I'm in a brand new namespace. I type in dir, right? We've got nothing defined yet. We just have the vanilla variable names that we see when we start up a Python interactive interpreter session. So how do we create an array? Well, remember, it said that I had to declare what kind of array or what elements in the array, what they were going to hold. So what if I said I wanted an integer array, right? And I say integer array, and let's do, if I was to want to insert, and I want to insert something. If I hit, and actually before I can do that, if I hit tab twice here, right, you'll notice I'm not getting any help. It doesn't show me anything. And that's because in order to access the array, and this is interesting, right? So remember that the list, right, the list is the default built-in data type, not an array. An array is not by default available to you. I would actually have to import the array. So the list is available by default, and we've seen that. We fire up the interactive interpreter, we create a list, and off we go. But an array is not. So I would have to import the array module to get access to the library of functions that are in there. And so how do we see that? Well, what if I say dir array? And so we can see what's available to us. And there's a module called array, right? So what does that do? So if I were to say, whoops, I apologize there, hit too many keys at once. So if I was to say dir array dot array, and this is, it's kind of tricky, right? So the name of the module is array, and in the module, we've got this method called array. So, and when I import it, I'll show you the two different ways we can make this import happen that are to our, or two different ways to do it, one of which is to our advantage to not have to type array.array over and over again. And so here we can see what can be done by using that method. I can count, extend, I think there's an insert. Yeah, I can insert, right? So there's all kinds of things that we can do with an array. So let me go ahead and say import array. Now that's one way to do it, but now I would have to say array dot array when I wanted to use the array method that's part of the array module. So how can we get around that? Well, it's simple. I can simply say from array import array. And then I could even say as and give it a sort of a what's the word I'm looking for? Not a pseudonym, an alias. But I'll just say from array import array. And so now what we could do is I can declare an array and it's going to be integer type. And actually, what if we just did that? Right? So what if I were to say dir now? Right? So we see array, but it didn't really do anything. Right? So I'm going to say my int array. And then I'm going to assign it, whoops, A-R-R-A-Y. I'm not good at spelling that. For whatever reason, I always want to type A-R-R-A-R-Y. I just end up hitting that sometimes. So I've got this array. So let me go ahead and say type my int array. And it shows me that it's an array data type, right? But now let's insert some values in here. Because remember, I've declared this to be an integer array. So what happens when I say my int array dot, and if I hit tab twice, you can see that we get a nice list of the methods that are available that I can use here to get some values in there. And where's the one I'm looking for? There it is, dot insert. Whoops. Dot insert. And so I'm going to simply insert, and I think I have to put in the position. So we'll just say 0, comma, and again, the zero-based counting applies here as well. Just like lists start with element 0 as the first element, the arrays start with element 0 as the first element in the array. And so I'll say just the integer 1. So now what happens when I say my int array? So you can see that we get this array of type integer. That's what the little I in single quotes is representing here. And the value that's in there right now is 1. So what if I insert into, and I'll just insert right on top of that, and then we'll do it again. I'll do 3, I'll do 4. And so you can see I'm inserting values into my integer array. And look at how it's keeping track of the elements that I'm inserting into the array. What type of data structure is that? Yeah, it's a list. It's keeping it sort of in there as a list, but watch what happens. Again, here's the limitation of the array and why the list is preferable. Remember, the list, I can put any other data type in there. But when I go to do this and I say, oh, you know what? I'm going to put numbers, right? I want it to say numbers at the beginning. And what kind of a data type is that? That's a string. And what does it say? Type error, an integer is required, because when we create the array in Python, we have to define what data types are allowed to be members or elements of that array. All right. Let me go ahead and pull back up this. And so that is going to wrap up sort of this supplemental tutorial on how Python lists are implemented using CPython. And we talked about the different types or flavors of Python that you'll find out there. And we also took a look at the communities of practice. And specifically, we looked at StackOverflow, an absolutely amazing website that I highly recommend you sign up for an account, get on there and participate. All right, well, thank you so much for watching. That is going to complete this tutorial. Hopefully this has cleared up any confusion about Python lists, arrays, linked lists, and how Python actually implements lists using CPython. Thanks so much for watching. Now it's up to you to get out there and make it happen.